Hello dear student, welcome to the last lecture in programming in C++. This is lecture number 9. Hope you're familiar with whatever we have learned in our previous lectures. In this video, we will learn about basics of structures and pointers in C++, classes and objects, basic file operations, and we will learn about serial and sequential file and also how to read from a file and write to a file. Structures. Structures is a collection of variables of different data type under a single name. So far we have learned about many type of variables. We have learned about single valued variables such as int or float. We have learned about multiple element variables such as arrays. Now, structure is also another type of variable, maybe a collection of variable, that is under a single name I can store different type of variables. For example, in the previous programs we have done, if we need to save different variables, say a, b and sum, then we have to define every variable under different name. A have to be under a different name, b have to have another name, and maybe data type will be different. So for every variable we need to give a specific name, we need to give a special name. But in this case, I can define many variables under one name, one particular name. This will give a lot ease to my program, and my source file would look very simple, so that I do not need to think about different name for different variables. I can give different data types under a single name. This is how the structure helped me to reduce the size of my source file. For example, you can see here, to do a structure, we use a keyword struct and the structure name. Here my structure name is person. So I use a keyword struct to tell the compiler that whatever coming after this inside a curly braces is a structure, and here struct is my identifier or my structure name. And inside the curly braces, here see I have defined many variables. Name, which is a character, age, which is an integer, salary, which is a float. Remember, a structure ends with a semicolon, not like any other curly braces, the brackets we have ever learned. See, inside this structure, we can save the person's name, age and salary in the same structure without giving different identifiers for different structures. This is very helpful if we are using a number of variables, a number of things have to be stored under a certain category. For example, if you are trying to collect data of the students in your class, then there will be a set of data which you will have to collect. For example, you wish to collect the name, age, you wish to collect complementary subjects or etc. There will be a list of things which you need to collect, and these list of things such as name, age, complementary subject, etc. will be similar for many students. That is, from every student you wish to collect their name and complementary subject, right? So for every student you need not define 3 different identifiers. You can just define a structure, and inside that structure you can collect data from every student. Hope you are clear with structures. Now let us see how can we use the structures. See, I have defined a structure named struct person. Now there can be different persons. Say I have to get a survey from 25 persons and one among that is Regina. So I now create a variable. I now create a structure variable by the name Regina using the syntax person and whatever name it will be. So using this syntax person Regina semicolon, I have created a structure variable. And now I tell my compiler that regina.age is equal to 25. Then I am telling my compiler that the age of the person Regina is 25. Suppose I have created another structure person Tanuja and I am giving another command like tanuja.age is equal to 27. Then I am telling that inside my structure Tanuja, save the age of Tanuja as 27 and save the age of Regina as 25. So to access the structure variable or to give a value to the structure variable or get value from a structure variable, we use a dot operator. So what will we do first? First of all, we define a structure, a common structure with person. Now I am defining two different persons, person Regina and person Tanuja. And for every person, for person Regina, I can write person.name is equal to Regina, person.age is equal to 25. And for Tanuja also I can write person.Tanuja is equal to Tanuja and person.age is equal to 27 and so on. Therefore, I can save a number of similar data. This is mainly used to collect data maybe for a survey. I can save a number of variables under a same identifier. This is how the structure works. Now let us learn how to abstract or access data from the structures. We have seen that using the dot we can access a data from a dot operator. We can access data from a structure. Another way to access data from a structure is using a pointer. A pointer is a variable which holds the memory location to another variable. We can use pointers in many things such as strings or arrays or any other variables we have defined so far. In structures also we can define variables and pointers can be used to access data from the structures. A pointer is defined by the structure name, a keyword structure, a structure name and a star mark followed by a pointer. Therefore, what we do, we will give a struct, the keyword struct, then the name of the structure and a star followed by the identifier for the pointer. Here I have given the name of my pointer as PTR. And note as I can give any other name. Whatever comes after a star sign will be identified as the name of the pointer. So for example, I can say struct person star pointer or I can also use person star pointer. Okay, if you have not defined any other variable using the variable name person, then you can use person star pointer or else you can use struct person star pointer. Now the variable can be accessed such as inside a parenthesis you give star followed by the name of the pointer which you have already defined dot the field name is equal to variable. For example, you are saying if PTR is a pointer to the structure person, then without evoking the structure name person, you can say inside the parenthesis it is star PTR dot age is equal to 25. This can be used to insert data into the variable or it can extract data by saying cout within the parenthesis star pointer dot age will give whatever it is stored inside the pointer inside the structure person. See, inside the structure person, see we have two different structures, that is Regina and Tanuja so far here. So we define different pointers to different structure persons. That is maybe PTR1 for Regina and PTR2 for Tanuja. Then if we see out within the parenthesis star PTR 1 dot age, then you will get 25, and star PTR 2 dot age will give you an answer 27. Hope you are clear with pointers to structures. Now we will move on to classes and objects. Classes are also user-defined data types. They are similar to structures. In structures, we have given only data elements. Classes also define data elements as well as the functions operated on it. In structures, we have seen that we have collected a number of variables, but in classes, we will collect a number of variables and define some functions which is operated in between them. So data and functions in a class can be private, public, or protected. In case of a structure, whatever data given inside was public. But in the case of classes, I can define it as private, public, or protected. I can define whatever variables, that is data or functions, as private, public, or protected. That is, private is when I wish to use it within a certain bracket, curly braces only. Protected is when I can access to use it within that source file only, and public when I can use within all over the main file and within the source file completely. Now, an object is an instance in the class. For example, we have used pointers to access data from a structures. So we use an object to access data from a structure. When object is used to access data from a class. When a class is defined, no memory location is allocated to that, and when it is created, no memory location is allocated. When we create an object for a class, this is when the memory location is created for the class, and this is how we can access data from a class. Hope you remember how we have defined a function. We have declared a function in the beginning and defined the function later on, maybe outside the main function or before the main function, however it's possible. Just like that, we can define the entire class maybe outside the variable, outside the main function or before the main function. And we can access data within the main function from the class using objects by giving the keyword class, class name, whatever class name we have already declared, and the object name by semicolon. By this, I am telling the compiler this particular object belongs to this particular class, and inside it I can use object name dot something, whatever which is stored inside. Maybe object name dot age will give the whatever data is stored inside the age within that class which is identified by the object name. A class can be identified outside or inside the main function and is evoked using objects. Now let us learn about files and its operators. File is a collection of data or character, or it can be text or a program, which is used to store permanently in a device. So far we have done many programs, and there is no way that we can store our output data for our future references. Suppose we are doing a lengthy program and we wish to store our output data for our future references, then we will use files. Files are used to store data into our device permanently. Now, C++ provides us with different mechanisms to handle a file and perform various operations in it. And file operations mainly come under the F header stream, that is IF stream or OF stream for input and output respectively, and they support input and output streams from the file. That is, we can give data into a file and also we can read data from a file while doing another program. So basic file operations includes creating a file, that is opening a file, reading data, we use read, writing new data or closing a file. Creating a file or opening an existing file can be done simultaneously, that is using the same syntax. If you use a syntax, say my file, then open my file, then if there is a file named my file, then it will open. If there is not a file named my file, then the compiler will create a file and open it. This is how it works. And I can read data from a file, I can write data into a file, and also I can close a file. Closing a file is done automatically when a program is terminated, or else you can give command to close the file. There are different types of files in which the data is being arranged. There are serial files. Inside serial files, the data are entered in the order of their creation. That is, the first created data will go to the first memory location and the second created data to the second and the third as follows. So it is ordered, all the data entered is in chronological order. We use these files when we access data also in chronological order. That is maybe in transaction recordings or something. That is when we have to access data in the chronological order itself, then we will write data in chronological order using serial files. The second type of file is sequential file. In sequential file, the data is not stacked in chronological order. It is stacked using under some key field. It is when we give data to a sequential file, it will find a spot in which a box in which this data will fit into, and it is already arranged inside the file. So to access data from a sequential file, we should know under which keyword that particular data is stored. There can be many keys. There can be primary keys, secondary keys under which the data can be stacked and arranged beautifully so that there is no mess in data. It's already arranged completely very well. There are another type of file, that is random file. In random file, the data given is stored in random, not in chronological order or not in sequential file, but there are some predefined relationship between the keyword and its location so that we can access data from a random file also without much difficulties. So now let us learn how to write into a file. So we have opened a file and we have to write into some data. We have got some result and we have to write it into a file. So we use a file, for writing into a file, we use an insertion operator. This is our insertion operator, hope you remember, which we use with the cout. Writing into a file is efficiently like something like a print or cout operator. So we use this insertion operator to write something into a file. So to write something into a file, we have to open that file with O stream, that is output stream, give my file. My file is the keyword to use, that is open a file, and within the braces you have to give the file name .text, and after that my file. Without cout, you give my file and an insertion operator and write whatever you want to write inside it. Here it is just a string. So whatever you wish to write and close with a semicolon. If this was a serial file, it will go in chronological order. If it was a sequential file, then it will go to the data which is similar to this data. Now after that, you will close the file using myfile.close and a parenthesis. Hope you are clear with how to write data into a file. And let us see how to read data from a file. To write data into a file, we have used insertion operator. So to read data from a file, we use an extraction operator similar to cin. So that is, we access data from a file, take data from a separate file into the function. This is something like cin. So we use an extraction operator. So to write a file, we have if stream. We use if stream as the header file, which is derived from the input stream. So the syntax is if stream my file. Here I have a mistake, pardon me. We use if stream my file, and within that you will give the file name.txt. If there is a file named file name.txt, then it will open the file or will create a new file. Okay. To read something, you have to open an existing file. Now we can get data. Using an insertion operator by using just like what you have done, my file and insertion operator, and whatever you wish to get ended by a semicolon. Now, in the case of reading from a file, it is somewhat different from writing to a file. To write to a file, you just need to specify what is to be written inside it. But from reading from a file, you have to specify the location and the data type which have to be read from it, because you doesn't need the entire data which is been recorded inside the file, or you didn't need any random data. You need a specific data. So it is very important to tell the compiler which to be read. So for that, we use a while program and we give an instruction to read whatever data which is needed for my file. If I need whatever data which I have read to be couted to the output sheet, then I can use a cout. If it doesn't, I can ignore this step. And after getting enough data, I can close file just by myfile.close. So this is how we read or write from a file, and these are basic file operations. So dear student, by this we come to the end of our chapter Programming in C++. Hope you are clear with how to do programming in C++, how to execute program, how to write programs, etc. Now we will see in some practical lessons which will be conducted live using the link will be shared in your Google Classroom. Hopefully we can meet using Google Meet after your examinations. So see you in the live classes. Thank you.